Question in the NHT paper of 2021 exam 1 gave us an activity table with duration and immediate predecessors, and the question was to find the number of activities that cannot be delayed. Now, knowing our theory, obviously the activities that cannot be delayed are the ones that are on the critical path. So the easiest way to address this question is to actually draw the network diagram, which often students find difficult, but there are a few things that you could do that would enable you to draw it more easily. I saw that B and D were two activities which had the same immediate predecessors B and D, F and G. So what I did was I drew B and D first, and which led off to F and G, and then I tried to extend this network diagram in both directions, and I saw the predecessor for B was A, and maybe I should have actually just drawn B straight instead of and D that way, and predecessor for B was A, and the predecessor for C also was A, but D arises from C. So that was C. So A has been drawn, B, the immediate predecessor is A, completed. C, the immediate predecessor for A, is completed. And D, the immediate predecessor is C, has been drawn. E, the immediate predecessor is C. And if you look down the table, you'll find E and G are both predecessors for H. So take this particular edge taking off from C towards G, and that will be your E. F we've drawn already. G we have. H takes off from E and G, but well, H joins F, so that's H. And I takes off from F and H, and J takes off from I, and K takes off from E and G. Now I think what students often got confused was, where does K go? Now in a question like this, you can just join it to that very end over there. And that is your activity network, which I have drawn previously, and it's the same as this one. Now, in order to calculate the activities on the critical path, you have to do a forward and a backward scan. So in order to do a forward scan, we put boxes at every vertex, like I have done. And we start with a 0 here. We start with, so A duration is 9, 0 plus 9 is 9. And then we go along B, 9 plus 7 is 16 along this edge. That's the choice over here. And along C, 9 plus 5 is 14. And as we go along D, 14 plus 3 is 17. Now, in a forward scan, we always choose the greater value. So in the box here, we put the earliest starting time as 17. Now, the choice was between these two edges that are coming to that particular vertex. Now, we continue along F. 17 plus 4 is 21. And if we continue along G, 17 plus 4 is 21. But here there are two options here, because if you come along E, 14 plus 6 is 20, and the greater number being 21. And so along H, 21 plus 2 is 23. Now there is an option here of 21 and 23, and the greater number is 23. Now going along I, 23 plus 2 is 25. That's this one here. And 25 plus 5 is 30, which is the complete finishing time. Now, if we do a backward scan, we start with placing 30 in that last box there, and 30 take away 5, which is duration of J, is 25. And then 25 take away 2 is 23. And then if we go along F, 23 take away 4 is 19. And at this vertex, there are, in the backward scan, there's a choice here and a choice here. So if we come back from the 23 here and along H, 23 take away 2 is 21, and 21 take away 4 is 17. And you know, in a backward scan, when you have to make a choice between two values, you take the smaller one, and that's 17. Now going along B, 17 take away 7 is 10, and 17 take away 3 is 14 along D, and that's 14 here. Now if you go along C, 14 take away 5 is 9. Now here there are two choices being made here. The choice between 10 and 9, the smaller value is 9. And 9 take away 9 is 0. Now we need to find the critical path. So we go ahead and look at all those boxes where the earliest start time is equal to the latest start time. But besides that, I prefer to actually go along the network to these boxes, adding the earliest start time to the duration. So we start with 0. So this box has obviously both earliest start time, latest starting time the same. So 0 plus 9 is equal to 9. So that's 1. And then I have an option either to go 9 plus 5 is 14 or 9 plus 7 is 16. Obviously, I'll choose the 9 plus 5 is 14 option, because that gives me 14 and 14 here. And then 14 plus 3 along D is 17, which is that, and both are equal there. And then earliest start time of 17 plus 4 is 21. And I see that they're the same here, so go along that way. And then 21 plus 2 is 23, and 23 plus 2 is 25, and so the number of activities, if you count them, 1, 2, 3, 4, 5, 6, and 7, and the answer is 7.